Welcome to the Ship. Today we are going to discuss Naval Act 2 Simpson's rules to find out the BM transfer and BM longitudinal, which is coming in the part 1 numericals for 25 marks, and it's very simple. And in this video we are doing the past paper solution also for particular Simpson's rules numerical, which is coming in the achievement phase 2. So let's begin this video. The Simpson's rule. The first rule: when the total number of ordinates are odd with a minimum of 3 Simpson's multiplier are 1, 4, 1, first and odd must be 1. 2 is used as the intermediate between Simpson's multipliers. So which we are going to use ordinate into Simpson multiplier is equal to product of area, or we can say product of volume. Sum of the product, then we have to add, and then the taken is SOP. Total area or volume is equal to h by 3 into sum of product. Simpson's second rule is says when a minimum ordinates are 4 and additional 3 thereafter, Simpson's multiplier are 1, 3, 3, 1. The first and last multiplier must be 1. 2 is used as intermediate between Simpson's multipliers. So ordinate into Simpson multiplier is equal to product of area, or you can say volume of the area. Sum of the product are then taken SOP. Total area or volume is 3h by 8 into sum of product. So where h is equal interval between ordinates. So BM transfer value is, formula is BM transfer is equal to I center line upon volume. When horizontal half ordinates indicated water plane, using first half an ordinate for calculating moment of inertia about center line, as ICL is about the center line. To find moment of inertia about center line ICL, H is equal interval between the ordinates. So this is a way we draw the diagram and we'll solve this. If only MI required, then M4 is equal to SM into 1 by 2 ordinates 3 for Simpson's first rule. So area is equal to h by 3 into SOP into 2 because we are taking half ordinates. So moment of inertia about center line ICL is equal to h into SOP 2 into 1 by 3 into 2 and divided by 3. BM transfer formula is MI center line upon volume BM longitudinal is equal to ICOF upon volume. So when horizontal half ordinate indicate water plane area, so we'll take from the up perpendicular. Use lever from the up perpendicular for calculating moment of inertia about up perpendicular. Then moment of center of rotation equal to MI after perpendicular minus area into LCF ka square. To find area LCF and second moment about up perpendicular, lever from the up perpendicular. So we use this table. How we use table? We solve during the numericals when we solving the past MMD papers. So for Simpson's first rule, area is equal to h by 3 into SOP and into 2 because we are taking the half ordinate, so total into 2. LCF is equal to SOP2 upon SOP1. Moment of inertia about up perpendicular is equal to IAP up perpendicular h by 3 SOP3 into 2. So ICOF is equal to IAP minus area LCF ka square. So BM longitudinal is equal to ICOF upon volume. Okay, so this is all the theory and the numerical parts. Now we are going to solve the 6 numericals with all the past papers. If you solve this, your 25 marks in your pocket. Okay, so our first question is the half ordinates of the vessel water plane area spaced 25 meter apart are 0.4, 14.5, 26.6, 34.0, 37, 37.3, 37.1, 35.8, 28.8 and 6 meters respectively, commencing from the forward end. If the seawater displacement of the vessel up to that water plane is 1,50,000 tons, calculate transfer BML and longitudinal BML. Okay, so half ordinates, one things, then seawater displacement, then this is given in the displacement in tons. Need to find transfer BM and longitudinal BM. Okay, so let's solve this numerical. So first we have to find out BM transfer. So BM transfer formula is moment of inertia center line upon volume. Okay, now we require all this to put this formula so that we can find out the BM transfer. Since we know that mass is equal to volume into density, correct? Mass is given in the question 1,50,000 tons. Volume we don't know, into density seawater is 1.025. So V is equal to 1,50,000 tons divided by 1.025. So we get a volume is equal to 146,341.46 meter cube. Okay, so in the formula which we are discussed, BM transfer is equal to moment of inertia central line upon volume. We get volume. Now we need to find MICL, moment of inertia at center line. Okay, then we find out this ordinates. H is equal to 25 meters. H is equal to 25 meters given in the question. So given in the question. Okay, now we make the tables. Okay, so we'll make the table. The half ordinates M system multiplier, multiply, we get the product 1 is equal to M2, then again half ordinates, then product 2 M3, then half ordinates, then SM, then product 3, it's called M4. Okay, this is the way we have to solve. So now put the value what is given in the question: 0.4, 14.5, 26.6, 34, 37, 37.3, 37.1, 35.8, 28.8 and 6. Okay, so total number of half ordinate is 10. So we use the number Simpson number, rule number 2. So 1 3 3 2 3 3 2 3 3 1, and then multiply half ordinates and SM. So we get the 0.4, 43.5, 79.8, 68, 111, 111.9, 74.2, 107.4, 86.4 and 6. Same again, we have to write half ordinates and then multiply with this 2, and again we have to multiply this, so we get the product 3. Now we are doing directly here. So now we come to here 0.4 to the power 3, because it's here 1. If you see this 1, this 2, so it will come here 3. So we'll do directly. Okay, 14.5 into raised to 3, 26.6 to the power 3, 34 to the power 3, 37 to the power 3, 37.3 to the power 3, 37.1 to the power 3, 35.8 to the power 3, 28.8 to the power 3 and 6 to the power 3. The same multiply 1 3 3 2 3 3 2 3 3 1. Now multiply these two and we get the value is 0.064, 9145.87, 5646.3.288 78608 151959 155685.351 102129.62 137648.136 71663.616 and 216. Okay, now SOP1 we need to all add to add and 688.6, and SOP2 all add and we get 76351.8.94. okay, now we used moment of inertia, the first formula, so 3h by 8 into SOP. okay, SOP2 into, when we calculate moment of inertia we used to 1 by 3. okay, and since it is half ordinates we need to full, so multiply by 2. so put the value, h is value is 25 given in the question, divide by 8 into 76351.8.94 into 1 by 3 into 2. so we get moment of inertia is equal to 4771993.375 m to the power 4. now BM transfer is equal to mi central line upon volume. so put the value 4771993.375 divided by 146,341.46. so BM transfer is equal to 32.609 meter. okay, this is first part. Now we have to calculate BM transfer. Now we need to calculate BM longitudinal. so BM longitudinal we take from the off perpendiculars. okay, BM transfer done. BM longitudinal, when we calculate BM transfer we take half ordinates and Simpson multiplier, but when we calculate longitudinal then we have to take the lever. We don't calculate here the system multiplier. okay, we'll see. If you see this 2-3 numerical you will understand. okay, now BM longitudinal formula is mi moment of inertia center of rotation with us about volume. okay, now we have to calculate all this to get BM longitudinal. volume we already calculated earlier, so volume is equal to 146,341.46 meter cube. okay, and moment of inertia center of rotation is equal to moment of inertia up perpendicular minus area into LCF का square. what is area? we are going to use rule number 2. okay, so 3 into h into SOP 1 into 2 and divided by 8. 3h by 8 into SOP, and since it is half ordinates we need to full, so we multiply by 2. what is LCF? how we get LCF? SOP 3 divided by SOP 1. so moment of half perpendicular is equal to 3h into SOP 4 into 8, and since it is half ordinate we need full, so into 2. okay, this way we get all this value. so first of all we have to make that table. okay, so let's write half ordinates, which call m, system multiplier, then SOP1 m square, lever SOP2, and again lever SOP3. so this is a difference for the mi moment longitudinal mi transfer. for longitudinal we have to make this type of diagram. okay, put the value which is given in the question. half ordinates 14.5, 26.6, 34, 37, 37.3, 37.1, 35.8, 28.8 and 6 meter. So 1332, 332, 331. Multiply. So 0.4 into 14, 3.5, 79.8, 68, 111, 111.9, 74.2, 107.4, 86.46. Now the lever. Since is the half in the question, it is given forward, and we need to longitudinal with respect to aft perpendicular. So aft, that means it's coming forward here. Okay, this is forward and this is aft. So lever will start from the aft, no? So we have to take from the aft. 0h, 1h, 2h, 3h, 4h, 5h, 6h, 7h, 8h and 9h. Multiply SOP1 and lever, so we get 3.6h, 348h, 558.6h, 408h, 555h, 447.6h, 222.6h, 214.8h, 86.4h and 0h. Again we have to same 0h, 1h, 2h, 3h, 4h, 5h, 6h, 7h, 8h, 9h. Again we have to multiply these two. Okay, 32.4h ka square, 278.4h ka square, 3910.2h ka square, 2448h square, 2775h square, 1790.4h square, 667.8h square, 429.6h square, 86.4h square and 0. Now we'll add all these and we get 14923.8 h square. All these add 2844.6 h. This is SOP4, SOP3. We need to add this all. 688.6 is SOP1. Okay, this much clear. Now we have to put formula. Since we know that, okay, we know that the formula is mi central of rotation is equal to mi moment of inertia half perpendicular minus area into LCF ka square. So mi AP is equal to 3 into h into SOP4 divided by 8 into 2, because we have to take 2. So 3 into 25 into 14923.8 h square into 2 divided by 8. So 3 into 25 into 14923.8 into 25 by square divided by 8 into 2. So mi AP is equal to 174888281.3 m to the power 4. Area is equal to 3h into SOP1 divided by 8. Half ordinates we record full ordinates into 2. 3 into 25 into 688.6 divided by 8 into 2. So area we get 12911.25 m square. LCF is equal to SOP 3 upon SOP 1. So 2844.6 H divided by 688.6 equal to 2844.6 into 25 divided by 688.6. So LCF we get 103.27 meter. Now put all this value in the MI center of rotation is equal to MI arc perpendicular minus area into LCF ka square. So 174888281.3 minus 12911.25 into 103.27 का LCF का square. So is equal to 174888281.3 minus 137707850. So MI center of rotation is equal to 37180,431.32. Now BM longitudinal is equal to MI center of rotation upon volume. So 37180,431.32 divided by 146,341.46. So BM longitudinal is equal to 254.067 meter. So this is our answer. Okay, so let's move to the next question. Our next question is: an undivided DB tank of length 18 meter has following half ordinates of water line at equal intervals. Measure from the forward bulkhead the 2, 2.8, 3.9, 5.2, 6.7, 8, 10.1 respectively. Fuel oil of RD 0.9 is loaded to a sounding of 0.8 meter in the tank. Assume the tank is well sided. Determine the kg fluid in the final condition at the displacement of 20,000 ton and kg is 10 meters. To find the kg fluid, okay, so let's see how we'll upload. This is also past MMD paper, very simple, for 35 marks. Okay, we'll solve this also. Okay, solution: H is equal to 18 meter and number of ordinates 1, 2, 3, 4, 5, 6, 7. So 7 minus 1, so 18 divided by 6 is equal to 3 meter. H value is 3 meter, correct. Kg fluid given in the question is kg plus FSC. FSC is equal to FSM upon displacement, correct. FSM is I into di upon W, and what is I? I is equal to mi central line. So we need to find out this value. Then we have to put this value into here. Then we get this. Then we get this, and then finally we get this. Okay, so let's move to the table. Okay, so table is ready. Half ordinates m system multiplier product m square into half ordinates product m3 half ordinates system multiplier product m4. Okay, so put the value in the formula: 2, 2.5, 3.9, 5.2, 6.7, 8 and 10.1. So it's 7. Either we use rule number 1 or rule number 2. So if both use, we always use rule number 1. So 1, 4, 24241 multiply 2 1 2 10 7.8 20.8 13.4 32 10.1. okay, so add and we get 96.1 SOP1. now again half ordinates, so 2 ka square into 10 ka square into 7.8 ka square into 20.8 ka square into 13.4 का स्क्वायर 32 का स्क्वायर 10.1 का स्क्वायर into 1424241. okay, but this value we don't know it. okay, this is only for the understanding purpose in order to calculate this one. Directly we come to the number 3. so half ordinates 2.5 to the power 3, 3.9 to the power 3, 5, half ordinates 2 का क्यूब 2.5 का क्यूब 3.9 क्यूब 5.2 क्यूब 6.7 क्यूब 8 का क्यूब 10.1 का क्यूब, because here 2 का क्यूब 2 का स्क्वायर, here 2 का स्क्वायर, here 2 का क्यूब. okay, same system multiply by 4 2 4 2 4 1 multiply 8 62.5 118.64 562.43 601.526 2048 and 1030.30. so we add and we get 4431.39 m to the 4. this is SOP4. so MI center line is equal to H into SOP4 into, when we use ordinates, 1/3. okay, and H/3 is the formula, half and we need full, so multiply by 2. so 3 into 4431.39 divide by 9 into 2. so MI center line is equal to 2954.26. now area is equal to row number 1, so H/3 into SOP1. okay, into half ordinates we require full, so into 2, so 3/3 into 96.1 into 2. so area is equal to okay, what is volume area into sounding, that means area into length, breadth into height is equal to volume. so area we calculated 192.2 into sounding given in the question 0.8. so volume is 153.76. mass is equal to volume into density. volume 153.76 into density is 0.9 given in the question. so mass is equal to 138.384 ton. now since Fs is equal to I into Di, we already discussed earlier, into displacement, so I is equal to 2954.26 into density 0.9, Di is density, into displacement is 20138.38. Okay, so FSC is equal to 0.132 meter. Now W kg vertical moment, initial 20,000 given in the question, kg 10. We need mass, we calculated 138.384, then kg is 0.4, so 20,000 into 55.36. add this 20138.38, add this 200,055.36. Okay, so final kg is equal to final vertical movement upon final displacement, so is equal to 200,055.36 divided by 20138.38. so final kg is equal to 9.934 meter. FSC is equal to plus 0.132 meter. Okay, so kg fluid is equal to 10.066 meter. So this is our answer. Okay, let's move to the next question. Past MMD paper. Okay, our next MMD past paper also. There is total 6 type of numerical, which is every time they are repeating the same. They are not changing anything. So if you practice with this all the 6 numericals, you are not going to lose this 25 marks. So my suggestion is to practice this 25 marks 6 question. It's hardly 1 hour video maybe. Let's see. Okay, a question is, a vessel of length 200 meter, displacement 65907.5 tons, kb 5.9, kg is 8.9 meter, has the following equally spaced half ordinates of water plane commencing aft. So commencing aft is given 0, 10, 13, 14, 14.2, 14.3, 14.1, 14, 11.5, 6.2 and 0.2 meter respectively. Calculate her change of trim if 500 tons of weight already on board is shifted 60 meter longitudinally. Okay, so let's see. First I will give you a hint how will this question we have to approach. Okay, length is given already 200 meter in the question, and displacement is given 65907.5 ton. kb is given in the question 5.9 meter, kg is given in the question 8.5 meter. Small w is 500 ton, d is 60 meter longitudinally. Okay, what is formula of change of trim? Trimming moment upon mctc into 100. What is trimming moment? W into D upon mctc into 100. And what is mctc? W into GML upon 100 into L. And what is GML? KML minus KG. Okay, so what is KML? KB plus BML. And what is BML? I upon V. And what is I? MI center of rotation is equal to MI up perpendicular minus area into LCF ka square. Okay, so all we need to find out, the question is we need to find out this, so that we can find out this and this. Okay, So this is the question requirement. Indirectly they are what? I. Okay, so let's solve this question. H is equal to 200 meter minus 11.1 to 11 minus 1 is equal to 200 minus 10. So H is value is 20 meter. Okay, now we make the tables. Okay, so half ordinates, system multiplier, product, m square, lever, product, lever, product. Okay, so it is 11, so rule number we are going to use 1. So 0, 10, 13, 14, 14.2, 14.3, 14.1, 14, 11.5, 6.2, 0.2. So 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. Now multiply 0, 40, 26, 56, 28.4, 57.2, 28.2, 56, 23, 24.8, 0.2. Add, so we get 339.8. SOP1. Now lever, so aft from the start, from the aft is given, so 0H, 1H, 2H, H, 4H, 5H, 6H, 7H, 8H, 9H, 10H. Now product and lever multiply, so we get 0H, 40H, 52H, 168H, 113.6H, 286H, 169.2H, 392H, 184H, 223.2H, 2H. Now 0H, 1H, 2H, 3H, 4H, 5H, 6H, 7H, 8H, 9H, 10H, 0H का square, 40H square, 104H square, 504H square, 454.4H square, 1430H square, 1015.2H square, 2744H square, 1472H square, 2008.8H square, 20H square. So we get 9792.4H square. So P3, and here 1630H, SOP2. Now area is equal to H by 3 into SOP. Half ordinates we need full, so multiply by 2. So 2 by 3, 20 by 3 into 339.8 into 2. So 4530.67 meter square is area. LCF is equal to SOP2 divided by SOP1. So 1630 into H divided by 339.8. So 1630 into 20, H की value, and 339.8 then LCF is equal to 95.938 meter. Moment of inertia half perpendicular is equal to h by 3 into SOP 3 into 2, so 20 by 3 into 9792.4 h square into 2, so 20 by 3 into 9792.4 into 20 to the power into 2. MI up perpendicular is equal to 522261 33.33. MI center of rotation is equal to MI up perpendicular minus area into LCF square. Now put the value in the formula. 6133.33 minus 4530.67 into 95.938 का square equal to 52226133.33 minus 4170.0739.04. So MI center of rotation is equal to 10525394.29. So BM longitudinal is equal to MI up perpendicular upon volume. So 10525394.29 divided by 64300. So BM longitudinal is equal to 163.691 meter. What is KML? KB plus BM. KB plus BML. KB is given in the question. 5.9 plus BML we just calculated. So KML we get 169.59 meter. That is GML. KML minus kg. KML 169.59, 1 kg 8.5 is given in the question. So GML is equal to 161.09 meter. MCTC formula W into GML upon 100 into L. So 65907.5 into 161.09 divided by 100 into 200. So MCTC is equal to 530.85 T. Now change of trim formula is trimming moment upon MCTC into 100. What is trimming moment? W into D upon MCTC into 100. Put the value of 500 into 60 given in the question. MCTC 530.85 into 100 is equal to 30,000 divided by 53085. So change of trim is equal to 0.565 meter by stern. So this is the answer of question. Our next question is the breadth of a vessel water plane of a vessel 180 meter length displacing 20,000 ton in water of density 1.005. Measure at equal spaced intervals from forward are 0, 5, 11, 18, 29, 29, 22, 18, 12 and 9 respectively. Calculate the transverse BM. Okay, this is also past MMD paper. Let's solve. But there is one trick. Length is 180 meter given, displacement is given 20,000 ton, intensity 1.005, and we need to find BM transfer. Okay, so note for this, since moment of inertia is required with respect to fore and aft axis through center of rotation, we convert to half breadth and then double. Okay, generally if you see the half ordinates given, but here it is not mentioned half ordinates. Okay, with full breadth we can not do. Okay, so generally if you see the all the question is half ordinates given, only this question is not mentioned half ordinates. So whatever given we convert into half ordinates, then again we have to multiply. Okay, because moment of inertia is required with respect to forward and aft axis throughout the center of rotation. Okay, so let's solve this question. Since we know that BM transfer is equal to I upon center line upon volume, where and H is equal to 180 minus number of ordinates minus 1, so 10 minus 1 is equal to 180 minus 180 divided by 9 is equal to 20 meters. Okay, volume is equal to mass upon density. So mass is given 20,000, 1.005. So we calculate the volume. Now we'll make the table. Okay, so half ordinates, system multiplier, product, half ordinates, product, half ordinates, sum and product. So this is M, this is M square, this is M3 and this is M4. So what is the ordinates given? We have to half. So 0, 2.5, 5.5, 9, 14.5, 14.5, 11, 9, 6, 4.5. So it's 10, so we use rule number 2. So 1, 3, 3, 2, 3, 3, 2, 3, 3, 1. Okay, since we need to calculate only the BM transfer, so I required M4, so need not to calculate this all, this one, this one, this one. Directly I am coming here. So 0 cut cube, 2.5 का cube, 5.5 का cube, 9 cube, 14.5 का cube, 14.5 का cube, 11 cube, 9 का cube, 6 का cube, 4.5 का cube. System of here same 1, 3, 3, 2, 3, 3, 2, 3, 3, 1. Now multiply, so we get 0, 46.875, 499.12, 1458, 9145.87, 9145.87, 2662, 2187, 648, 91.125. So we'll add this and we get 25883.86. Okay, so I center line is equal to 3h into SOP divided by 8 into 1 by 3 into 2. So 3 into 20 into 25883.86 into 1 by into 24. So I center line is equal to 129419.3. So BM transfer is equal to I center line upon volume is equal to 129419.3 divided by this volume 19900.5. So BM transfer is equal to 6.503 meters. This is our answer. Okay, so the last question is this type of numerical. The half units of vessel water plane area is placed 20 meter apart are 1, 13, 24.5, 33, 35, 35.3, 34.8, 31, 25 and 5 meter respectively. Commencing from forward end, if the salt water displacement of the vessel of that water plane area is 11,500 tons, calculate her transfer BM and longitudinal BM. The similar, the question number 1 we solve like this. Well, this is all the 6 is a repeated question. We'll solve this. You can verify your answer. Okay, so let's see. H is given, already given in 20 meter in the question itself. Since we know that volume is equal to mass upon density, 11,000 divided by 1.025, so volume we get 112195.12 meter per cube. Okay, so first we need to find out BM transfer. BM transfer formula is I upon volume. Volume we already know, and what is I is equal to M4. We have to make diagram. Okay, so half hour units M system multiplier product M square, half hour units system multiplier product M3, half hour units system multiplier and product M4. So we record this one, so we directly come to this one. Okay, so 1, 13, 24.5, 33.0, 35.0, 35.3, 34.8, 31, 25 and 5. So it is 10. So system multiplier number, rule number 2, 1332, 332, 331. Okay, so we know it, so directly we come to here. 1.0 का cube, 13 का cube, 24.5 का cube, 33 का cube, 35 का cube, 35.3 का cube, 34.8 का cube, 31 cube, 25 cube, 5 का cube. Here 1 3 3 2 3 3 2 3 3 1. Okay, so multiply 1 6591 44118.37 71874 128625 13196.93 84288.38, 89373, 46875, 125. So we get 603831.684. So I equal to rule number 2, 3h by 8 into SOP into 1 by 3, this is formula, into 2. So 3 into 20 into 603,831.684 into 1 by 3 into 8. Is equal to 150,957.9.21. So BM transfer is equal to I upon V. So 150,957.9.21 divided by 112195.12. So BM transfer we get 13.455. So when you total, so BM transfer into 113.455 into 2. So BM transfer is equal to 26.910. Now BM longitudinal also we need to find. So BM longitudinal is equal to I upon volume. I is equal to MIAP, moment of inertia up perpendicular, minus area into LCF square divided by volume. Okay, so half ordinates, system multiplier, product, lever, SOP2, lever, SOP3. So 1.0, 13, 24.5, 33.0, 35.0, 35.3, 34.8, 31, 25.25 and 5. So 1 3 3 2 3 3 2 3 3 1 139 73.5 66 105 105.9 69.6 93 75 and 5. Total 633. Then lever from the aft. So 0h, 1h, 2h, 3h, 4h, 5h, 6h, 7h, 8h, 9h. So 9h, 312h, 514.5h, 396h, 525h, 423.6h, 208.8h, 186h, 75h, 0. Then again lever. So 0, 1h, 2h, 3h, 4h, 5h, 6h, 7h, 8h, 9h. So 81 का h square, 2496 का h square, 3601.5 का h square, 2376 h square, 2625 h square, 1694.4 h square, 626.4 h square, 372 h square, 75 square, 0. 9h, and this is 13947.3 h square. Five two nine 9.8 and 5578920. So their area is equal to 3h by 8 into SOP1 into 2. So 3 into 20 divided by 8 into 633 into 2 equal to 9495 m square. LCF is equal to SOP2 divided by SOP1. 52998 divided by 633 is equal to 83.72 meter. Moment of inertia arc perpendicular is equal to 3 into h by 8 into SOP4 into 2. So 3 into 20 into 5578920 into 2. So we get 83683800. Moment of inertia arc perpendicular minus area into LCF का square. The value in the formula 83683800 minus 9495 83.72 का square. So we get 83683800 minus 66550 So I is equal to 17132.980.39. So BM longitudinal is equal to I upon volume. So 17132.980.39 divided by volume 112195.12. So BM longitudinal is equal to 152.71. So this is our answer. This all is the past MMD paper solution. This is repeated all several times. This repeated, they don't change any value even. So if you solve this is 1 hour video. So in a 1 hour you will score 25 marks. So hope your doubt is clear regarding the Simpsons for the achievement phase 2 Naval Arc 2. Still, if you have any doubt, write me in comment box, or you can WhatsApp my WhatsApp number. And best of luck for your examination. Thank you. Have a good day.